Hi, everyone, and thanks for joining us today. In this session, we're going to be talking about something we've been working on at GitLab that we're calling the 5-minute production app. My name is Darby, and I'm joined also today by Sri. We're going to tell you more about this project and how we use GitLab and Terraform to make it all happen. I'll start by giving some background on what we're trying to accomplish with this project, and I'll show a quick demo, and then I'll turn it over to Sri for the details on how it all works. So the goal of the 5-minute production app is to make it easy to deploy a production-ready application in just a few minutes. And the use case that we're focused on here really is for someone that's building something new. So maybe it's a new side project or a new startup, or just an idea that you're looking to get some feedback on. For any of these cases, getting the code off of your laptop and into the world is the best way to get feedback and to iterate. Things that we think are important here is that by doing this ensures that your application is running correctly on the internet from the beginning. It also ensures that you have a complete production-grade delivery pipeline from the start. So this means everything that you add to this application after that first commit is going to get deployed to production just like everything else. Because your code is live on the internet, now you can get feedback from colleagues and your potential customers very quickly. So to accomplish this, we created a specially designed GitLab CI template. And this template will build up production-grade application infrastructure in AWS. The template today will provision a full set of basic services needed for most web applications. So things like EC2, RDS, Redis, S3, and SES for email. We've also included SSL and secure networking in a VPC and automated Postgres snapshots right out of the box. So to make this work, it's as simple as including the deploy template in your GitLab CI YAML file. The other thing that you need to do is add a couple CI variables for your AWS credentials. Something worth mentioning here is that you can deploy to whatever AWS region you'd like simply by setting the region and the configuration. So I put together a very simple demo using Rails 6, which will show some of the basic deployments and some of the more advanced features for things like database migrations. First thing we'll do is we'll take a look at the README here. And this is the project in GitLab. And this in the README here, I've literally put all of the commands that I've used to generate this application. So the Rails new command, generating a scaffold for something called product in this application, and then configuring GitLab. So down here, we're going to create a new project in GitLab. We're going to configure some CI variables, and then we're going to add a Docker file and a GitLab CI YAML file. So we jump over here to the Docker file. In this file, it's a pretty straightforward Docker file. We're using Ruby 2.7. We're installing some things like Node and NPM and Yarn. And then we're doing a bundle install and a Yarn install, and then pre-compiling assets down here. And then finally, booting the application on port 5000. Over in the GitLab CI YAML file, you can see here we're literally including this one-line deploy template, which does all of the work for us. And then there's a few variables that we set in here. So we've got the db migrate variable, and this is the command that we want to run as the command that executes our database migrations. So in Rails, it's going to be Rails db migrate. In other platforms, it could be some other command, but this will execute on every deploy so that we ensure that our database stays in sync with our application code. The next thing we have in here is this pattern that we're using, which is gl underscore var underscore. And what we do with this is we use this as a way of establishing environment variables that we can then pass into the running application. So within your application is going to get Rails underscore env. And so what we're doing here is we're just setting Rails env to production. We've also got another example here where we set Rails log to standard out to true. So this is something that just gets us a little more logging information in production. And you can use this pattern for any other environment variables that you want to pass into. Lastly here, I'll talk about this CI commit ref protected. So this is a feature that we've included in the pipeline that will, if this feature is enabled, it will show a destroy step in the pipeline. So that means that as you built up all this infrastructure and maybe you decide you want to tear it down, you can just use that simple step to do that. That way you don't have to go into the AWS console and track down all of the pieces of infrastructure that were created. So once we add these files and commit our code and push, this pipeline will get kicked off in GitLab. So the pipeline has 3 steps that I want to talk about right now. The first one is just simply the build step, the Docker build. Second is the provisioning step, and this is where we run Terraform apply, and we go and create all that infrastructure in AWS. The first time this runs, it takes a few minutes. Just takes a while to spin up all those servers, and then subsequent runs are pretty fast. And then lastly, the deploy step. This is where we take that application that we built in the first step and then deploy it to that infrastructure. So if we look at the output from the deploy step here, we can see this towards the end, there is the URL now that we've generated for this application. So you can see it here. This is the application running in production. I can make a change. I can call this product 2. And we can see that it updates and everything works. So back to the slides. The last thing that I wanted to show here is that destroy step. So this shows when that environment variable is set. And this is a manual step that is part of the pipeline and is available if you want to clean up that infrastructure. It doesn't run automatically. You just click a button here and then that'll run and clean up everything for you. So the last thing that I want to show here is the configuration reference. This is in our documentation, and basically what this shows is all the different configuration options that we have as part of the 5-minute production app. There's a couple things that are worth noting in here. This is where you can control the instance sizes that you're deploying. So if you want a larger database or something like that, you can change that in the configuration. You can also set up custom domains this way as well. And then any other sort of configurations that get added in the future we'll add to this screen. So, and that's a quick overview of the 5-minute production app. I'll turn it over to Sri so he can show you how it all works. Thanks.
Hello, my name is Sri. I'm an enterprise solutions architect at GitLab. And in the next 20 minutes, I would like to explain everything I can about 5-minute production. If there is just one slide I could show you, it would be this one. It would be this image that explains everything that's possible with 5-minute production. But let's start with a simple definition. What is 5-minute production? It's a way for you to achieve production-grade infrastructure and production-grade DevSecOps processes for your project in under 5 minutes. It brings together the features and the offerings of GitLab, Terraform, and AWS, and tries to deliver everything in a simple, easy to consume package. It all starts with a GitLab project, as you can see on the top left of your screen. The GitLab project is where you have a Git repository with source code for your web application. It could be a Ruby on Rails application, a Python or a Django application. Maybe you use Node.js or Java. It really does not matter which language or which framework you use. This will work for everything. But the assumption here is that you have a web application inside a Git repository. Now, what we will do is we will try to achieve perfect GitOps. We'll start with the notion that every branch on your Git repo should translate to a web app deployment environment. So for example, if you have a production branch, that should translate to a production environment. If you have a staging branch, that should translate to a staging environment. If you have temporary feature branches, they should end up creating temporary feature environments. You decide. You decide if you want a long-lasting branch and long-lasting environment, or if you want short-lived branches and short-lived environments, you can achieve that by deleting your branches. The 5-minute production pipeline itself has got 3 steps: build, provision, deploy. Build stage is where we create a build and a package for your application. This application package is usually in the form of a container image, which gets stored inside the container registry of your GitLab project. Then is the provision step, where Terraform script actually gets executed and it provisions all sorts of hardware, or not hardware, forgive me. It creates all sort of infrastructure resources that you need on AWS. And finally is the deploy stage, which basically takes your packaged or the release version of your application, and then it takes the infrastructure that has been provisioned and actually merges to do. It takes your application and deploys it on the infrastructure. As you can see, what infrastructure gets created, we'll go into details a bit later. But this is the rough idea. A pipeline which will build, provision and deploy your application, regardless of which technology you use, which programming language you use, which framework you use, it should really not matter. And we want all of this available for you in under 5 minutes. Let's see how this is done. First, who is this for? Well, it's for somebody who has a web application. It's for a small startup or a team that has got a web application and they want production grade infrastructure and production grade developer operations as soon as possible. That's the first target user. The second target user is somebody who just wants to understand how to automate infra provisioning, how to automate software delivery, and wants to deliver something similar for their teams. So this could be something you use, or it can be something you learn from. Where does it all begin? It all begins with a commit. You should have a web application. So just imagine that you are now a development team with a web application. And your web application, of course, is hosted and pushed into a Git repository. And let's assume that your Git repo is actually hosted on GitLab. It does not have to be hosted on GitLab per se. It can be hosted on any Git provider that integrates with GitLab pipelines. Um, Things are usually pre-integrated with GitLab pipelines if you are using GitLab itself. So for the sake of this talk, I'm going to assume that you have a project that is running on GitLab. If you have a project that runs elsewhere, look up the GitLab documentation on how to integrate GitLab CI/CD and GitLab pipelines for your alternate Git provider. Now, the web application part. It can be any language, it can be any framework. We really don't care. We don't care as long as it can be containerized or as long as it can be packaged with Heroku build packs or as long as it can be packaged with cloud native build packs. You as the development team for the web application, you decide how you want to build and package your application. We really don't want to make this decision for you, but as long as your build process gives us a package we can use, we will deploy it. I will be showing you some examples, and in the examples, we'll go with the containerized application, which uses a simple Docker file. And I use this as my example because it's the um, broadest possible source or means of creating packages. I think most people will understand Docker files, so it would be very well or easily consumed by the audience. Let's talk about the automation part. You've heard me mention GitLab CI/CD or GitLab pipelines in this talk so far. What is that? Every time you create a Git event, pipelines are triggered, which means that your Git event could be a commit, it could be a push, it could be a merge, it could be a rebase, it could be creating a tag, whatever. Whatever is your Git event, it triggers a series of automations known as a pipeline. A pipeline simply is a set of jobs, and it's executed in a particular sequence. And these are basically the building blocks for automation. Let's put these two together. We get the 5-minute production pipeline, which is a pipeline that lets you build your application, provision infrastructure for your application, and 3 deploys your application. Optionally, you can also run step 4, which is to destroy, that is undeploy your application and destroy all provisioned infrastructure resources. But that's an optional step. We don't turn it on by default. The documentation tells you how you can turn it on if you need to. So I'll switch to my first demo. Let's have a look at the GitLab CI YAML. So this is my GitLab project. It's a Rails application, a basic bare bones Rails application. And I go to the GitLab CI YAML file, you will see that I'm including a template called the 5-minute production app template. This is all you need to do. By including this template in your GitLab CI YAML file, you have already achieved complete integration with 5-minute production. All the variables you're seeing defined here are optional, but let's just quickly have a look. In this case, it is a Rails application. So I've got a db migrate variable where I execute my bundle command to actually perform migrations on a database. This is a post deploy script that gets executed after every deployment. Then you have some variables to configure various properties of the infra resources that are created. We have a variable to basically enable destroy job so that I can actually show that to you in this demonstration. And we have some variables that I want to pass to my end application. That's that. The second part I'm going to demo to you is the branches. So you see that I have a Git repository, which has got right now 5 branches, 5 active branches. There are probably more branches which were created in the past or which are no longer used. But this is just a quick example of the branching flow. 5-minute production does not require you to use any particular branching strategy. Use what you like. In this case, we have a master branch, we have a stable branch, and we have a couple of feature branches. The third thing I want to show you is the pipeline itself. So I switch to the tab here, and you're seeing an example of the 5-minute production pipeline. As I said, it's got a few steps. It's got a build step. It's got an optional test step. In this case, the test step is not being provided by 5-minute production. It is being provided by something configured particular for this example project. So just ignore the test step, if you will. You've got the build step, you've got the provision step, you've got the deploy step, and you have the optional destroy step, which is a manual step that you have to press a button to execute. Let's come back to the slides. Let's talk about the build step. As briefly mentioned in the past, it builds and packages your web application source code. The generated package in this case is a container image. It is stored in the container registry. Every GitLab project has built-in registries for packages and containers. This could be, for example, container registry, npm for your JavaScript modules, Maven for Java, PyPy for Python, etc. All of this is there inside your GitLab project, so we just make use of it. One package is created for every pipeline execution, that is every code change. And distinct packages are created for every Git branch and Git tag. Packaged container images is later accessed in the deploy stage. We will see how it gets used later. Let's just have a quick look at the container registry. I go to the container registry over here. It's inside my GitLab project, packages and registries section, and then the container registry link. You will see a list of image repositories here. And you can already, if you look at the name, you know that it's got a container folder or a repository for every branch. If I look at the container images built for my master branch, you will see it's going to load a list of container images that it's been built. So here you have a list of container images built for the master branch. Let's move on. Let's talk about the second step, provision. What happens during the provision stage? It reads pre-configured AWS keys. So the access key, the secret key, and the default region. These are keys that you have defined for your project. So it just reads them. Note that if you are GDPR sensitive, you can define the default region. So you can say that please store all my data, all my applications only in EU West 2, which is the London location for AWS. You have that sort of control. Anyway, it reads these variables and it passes it on to the Terraform script that actually gets executed. This is the script that provisions your infrastructure. It treats every branch as a unique environment. and it's stateful. So the infrastructure is not deleted and recreated from scratch each time. No, it's stateful, and stateful infrastructure is maintained for every environment. So when I create a new environment, it creates new infrastructure. But when I push changes to the same branch or the same environment, it reuses the infrastructure that got created. The Terraform state itself is managed by GitLab, which means you have a unique state per environment managed in the same Git repo as the rest of your source code. And of course, you can connect to this environment via GitLab pipelines, or if you wish, you can also connect to this Terraform state using your local CLI. The second part is the AWS resources. What is it that the Terraform script actually provisions for you? The first thing it does, it creates a secure private network. That means it creates a VPC, a subnet, route table, etc., etc. It creates them for every environment. Within that environment, within that secure network, it creates a relational database. It uses AWS RDS to create a Postgres SQL database for you. This database has got daily backups enabled, and each backup is preserved for 7 days. So at any given point of time, you have daily backups for up to 7 days. And of course, if you perform the Terraform destroy, snapshots of this database get created. The next thing it creates for you is a caching layer. In this case, it is Elasticache with a Redis cluster. The cache, of course, is not persisted. It's a cache. So if you destroy your environment, the cache goes forever. Then, of course, you have the S3 bucket or the object storage. Your application might need an object storage. We also configure an email service, which is the AWS Simple Email Service. So your application is enabled and empowered to send out emails to your users. And finally, we create an EC2 instance, which is an Ubuntu 20.04 LTS instance, which has got port 80 and port 443 exposed to the World Wide Web. Here's a diagram for you. You have the internet, and the internet's edge service, so to speak, is this EC2 instance, which can be accessed by 2 ports. This also lives inside a VPC, a secure network, which contains various other resources. All of these resources, so the Postgres or the Elasticache or the S3 bucket or the simple email service, live within the secure network, and the EC2 instance is able to connect to them, which means when your application is deployed on this EC2 instance, your application can also access these resources while the rest of the internet cannot access them. And just want to highlight daily backups being enabled for your PostgreSQL. This is possibly the heart of it. So please treat PostgreSQL as data that is to be persisted. And by persisted, it really gets persisted, and you have backups and snapshots available for it. Now that we have the infrastructure, let's talk about deploying. Deployment, what are the preparation steps for it? The first is we have to fetch the deployment secrets from the Terraform state. How can we connect to the EC2 instance? How can we actually deploy our application there? Those secret credentials are available in the Terraform state. Second, fetching of a deployment environment from the container registry. So now that we can access the deployment environment, what is it that we deploy? That artifact, that container image that gets deployed can be accessed in the container registry. Step 2 is to actually deploy it itself. So we have a simple deployment script that deploys the application to the EC2 instance. While deploying the application, it provides your web application with credentials for the Postgres database, the Redis cluster, credentials required to send out emails, credentials required to access the S3 storage, and any other environment variables that you would like to provide. As you saw in my brief example earlier, we also have the ability to create post-deploy triggers. And in my example, I was creating a trigger to actually run the Rails migration. I'll just refresh your memory. Here's an example of a trigger being used to run this command after the deployment process. In this case, it's just rake migrate. Finally, what we do for you is we set up an SSL certificate with certbot. So Let's Encrypt provides you SSL certificates. You can connect your domain. So you can just define a domain name variable which connects the domain, and SSL certificates get created for your domain automatically. I mentioned Terraform state and I mentioned environments. So let's have a look again what that means. Let me first refresh your memory with the branches. We have these branches over here. So now if I go to my GitLab project, I select operations and I select Terraform, you will see that I've got Terraform state maintained for each of my branches. Every time a pipeline gets executed for these branches, it looks up these Terraform state and downloads it within the pipeline and actually works with it. So we completely enable stateful application deployments. Of course, through your Terraform CLI, you can connect to the state as well, or you can simply download the JSON and do whatever you want to. The second thing I'd like to show you is the environment. So these are environments. In this case, I've got one available environment and 6 stopped environments. And these are environments that get created when a pipeline gets executed and it completes the execution. So your application gets deployed onto each environment. As you can see, for each of these branches, you have a live environment with a URL that you can click and you can access. Let's move on. I'll talk a little bit about Auto DevOps. Auto DevOps is a series of additional reusable jobs, part of a larger pipeline, but they're reusable jobs that you have available, which means if you take Auto DevOps and you put it in 5-minute production, you can get a complete workflow for your application. So these could be running tests for your application. It could be running source code quality checks on your project source code. It could be running security scans, for example, static analysis, fuzz testing, dependency scans, and so on. Or you want to perform things like performance tests or license compliance. So you have all of these reusable pipeline jobs within GitLab, part of the Auto DevOps bundle, and you can pick and choose the ones you like. Of course, once you pick all of these, your pipeline gets a bit complex. So it started off with 3 jobs, and now you can see a complete pipeline will have a lot of different jobs. And these pipelines, of course, depending on the number of scanners you're running, they could take a while. But once your project reaches a critical mass, you probably want to enable all of these. What is the takeaway? Like, what can you take away from this talk? The first thing you can do is use 5-minute production. If you have a web application and you want to deploy to AWS without any headaches, use it as it is. It works great. The second is this can be a learning example for you. Get inspired, create your own infra as code setup, use Terraform, use the wonderful products HashiCorp has made available to you, and try to achieve GitOps in the true sense, which means your source code and your infrastructure live in the same repo. And I would like to leave you with this thought. Have we really achieved the complete convergence of GitOps with the 5-minute production? Let's see what we've achieved. We have the source code in the same GitLab repo. We have the infra as code, the Terraform scripts in the same GitLab repo. We have our release packages, the container images that we built in the same GitLab repo. We have the infrastructure state, that is the Terraform state, inside the GitLab repo. And we actually have the running environments with all the configs in the GitLab repo as well. So every aspect of your application is in one place. So in theory, or I would go a step further, at least in my experience in practice, this is possibly one of the most complete examples of GitOps I've seen so far. With that, I'd like to wish you a great day. I hope you are a little inspired. I hope you have the necessary inspiration to at least test it out one time. And once you test it out, of course, we're happy to listen to feedback. Like most or like almost every piece of GitLab project or GitLab product or GitLab solution, this too is open source. So please access it, please use it, and please share your feedback. Thank you so much.